Hello, today I want to show you a CPU I made, and there's two examples first. First example is calculating Fibonacci, and this is RAM cleaner. Calculating Fibonacci number, and second is calculating prime number. So if you look at this, it calculates prime number and quite fast. So when I decided to make a CPU in Factorio, there were some advantages compared to real life. First, in Factorio, I can carry many 32-bit numbers in one wire, so I don't need a huge bus. And second, one combinator can do a specific calculation like plus, minus, multiply in one tick. And finally, one combinator calculate once in an tick, and this is very important because the CPU don't have a register which contains data. It just sends a proper signal in proper time. So this is version 7.0 and have a lot of complicated things and hard to explain. So I'll show you a version 1.0, and this is version 0.0. You can see command container, counter, starter, RAM cleaner, decoder, ALU, and RAM. So if you see the RAM first, this is a basic structure, and there's two input, green wire and red wire, and there's two output, green wire and red wire. So in red wire there's I signal and O signal, and if I signal comes in green wire there's dot signal goes in. So if I signal equals 1, the dot signal passed through this signal and contained to this, and due to this the previous contained data was deleted. So the I signal is the index to contain data, and dot signal is the data to contain and if all signal goes to the red line, this gate is opened and sends the stored data. So you can control the RAM by OI and dot signal, and that signal just goes to the ALU directly, and it also goes to the register, which can't contain data. It just converts a previous dot signal into one signal, and in ALU the current signal goes in RAM, and previous dot signal is calculated and selected by A signal and goes through the green line and goes into the RAM again. So data circulates and calculated, and you can control this by OI and A signal. So this machine sends the OI and A signal. If you look at this star, it sends one tick of F signal, and that F signal this is counter which contains current command index. So F signal puts the current command index and plus is 1 and it goes to command counter. So next commander goes to the decoder, and in decoder the commands are delayed and goes to ALU RAM. So if you look at this, there's Cooper wire and box and steam inserter. And Cooper wire converted into I signal and goes in RAM, and red box is converted to DOS signal and also goes to RAM. So this command means store data 10 in index 1. And this inserter calls next command. So like this inserter is to F signal and calls next command. And next command is also storing 7 in index 2 like that. And if you see this, there's belt 1 and belt 2. This converted to O, so this will be O signal 1 and O signal 2, so it outputs the stored data, and this is converted to A signal, and this will convert it to I signal again, so it will add index 1 and index 2 and store in index 3. So index 1 is 10, index 1 is 10, index 2 is 7, and index 3 will 1 plus 2. 3? Oh, in first command there's 1 minus 2 equals index 3, so 3 is contained, and this ends the program. So this is 0.0 and 7.0 CPU has same structures, but it has other complicated system like the signal from ALU goes directly to command counter, so you can do if expression which jumps the command index more faster. And like this you can see the command counter, you can see the RAM. This is command counter and this is command container. All the things in this are decoder, ALU, and some input and output. And that's finished. I hope you enjoyed this video, and if you have some question, please leave a comment. Bye.